Okay, yesterday we talked about Rolle's theorem, and today we're going to talk about mean value theorem. Mean value theorem, you'll notice some similarities between them. If f is continuous on the closed interval, and if it's differentiable on the open interval, those are the two cases we had to have yesterday, then there exists at least one number in C where the derivative, the slope of the tangent line, equals, hopefully you recognize this as the slope of the secant line. So this, I'll go ahead and write that in there. The slope of the tangent is equal to the slope of the secant. It's much easier to see these again in pictures, so I've got some pictures drawn. This is mean value theorem. Notice how it is continuous on the closed interval and differentiable on the open interval. On both cases, continuous on the closed interval and differentiable on the open interval. This is the big part. The slope of the tangent, okay, so we're looking at tangent lines to the curve, is the same slope as the slope of the secant. So if you look at these pictures, I've drawn in right here the slope of the secant. Look how the slope of the secant, approximately right here, the slope of the tangent is equal. So there's one value of C in that case. On this next one, I neglected to draw in the secant line, so I'll do that really fast. So I'm looking at points where the slope of the secant is the same as the slope of the tangent. So it looks like that one I got off a little bit, but you guys would see that there's three values, and these are all approximations of that. So there's at least one number in that closed interval where that takes place. There could be more. Let's have a little discussion about what this really means. So what mean value theorem is really saying is basically if you were on a trip and you traveled an average speed of 60 on the trip, then at some point during that trip you must have at least traveled 60 miles an hour. So at some point along that trip, if you were averaging 60 miles per hour, you had to have been going 60 miles per hour at least once during that trip. Notice that Rolle's theorem and mean value theorem are very similar. It's just Rolle's theorem is a special case of the more general mean value theorem. Remember, Rolle's theorem requires three parts to its if. Not only does it need to be continuous and differentiable, but it also has to have f of a equaling f of c. And in mean value theorem, f of a is not equaling f of c. So on this first example, what we're going to do is we're supposed to copy this graph, and then we're going to sketch the secant line. So I'll do that with a highlighter as best I can, or maybe I'll just do that with I think a highlighter might be better. If I had a straight edge, it would make it way easier. So there's my secant line, and what I'm supposed to do is find points where those tangent lines to the curve are the same as the secant lines. So I will do so. I'll approximate that there's a C value about right here. So straight down, there's one C value. It looks like there's another C value right here where the slope of the tangent equals the slope of the secant. I'm not drawing that very straight, but there's a second value. And then there looks to be one more value about right here. So maybe this is C3. So we have now sketched any of those tangent lines to the graph that guarantees the mean value theorem. This next problem, we're supposed to explain why the mean value theorem does not apply to this open interval. Well, I'm going to just look at a graph in order to do that. This actually tells me to shift the absolute value graph 3 units to the right. So this is just a general sketch of what that looks like. I can see that mean value theorem does not apply because it is not differentiable at 3. So mean value theorem does not apply because f is not differentiable at x equals 3.